We just said this photo problem is a brain problem and that's why neural networks exist. But here's a twist. Pretend neural nets were never invented. How would an ordinary engineer still try to crack it? You'd be surprised how far they'd get. So picture a normal engineer, not a PhD, not a maths genius. An electronics person who knows circuits and crucially knows how to multiply an image by a matrix. That one trick is the whole toolkit here. Step 1. Multiply the image by a small grid of numbers. A photo is just numbers to a computer, and a matrix is a tiny grid of numbers. You slide that grid across the image and multiply. That's it. And the choice of numbers decides what you get out. Pick the numbers right and that grid cleans the picture. It wipes out the background noise, the messy, useless pixels, and leaves the important parts standing out. Suddenly the photo is far easier to read. Push it further with the right grid and you get edge detection. Everything flat goes black and only the outlines stay white. Now the shape of the thing, the arms, the legs, the wheels, pops right out at you.
Okay, the shape stands out now, but how do you actually tell the machine which shape it is?
You match it. Take the clean outline and compare it against shapes you already know using a similarity measure. Cosine similarity that scores how alike two shapes are. The catch, it can only say this looks like a man. It can't understand pedestrian. Chain it all together and you've hand-built an object detector. Clean the image, find the edges, match the shape. No neural network anywhere. And honestly, it works maybe 70 to 80% of the time. So neural nets aren't a different universe. They're the same idea but smarter. Instead of you handpicking every grid of numbers, the network learns them itself. Next, we climb from images to language, how LLMs actually work.